Hey everyone, my name is Lawson Roberts, and today I'm going to kind of walk through my MIS 670 final project that we did for class. So to start off, this was a very open-ended project. We could pick and choose whatever we were interested in, wanted to do. So since my major at K-State is supply chain and operations, I decided to look for a kind of supply chain news portal and kind of look through that text data and maybe see if we can find any correlation or uh, find interesting things that are considered trends in industry and things like that. So well, I found this apics.org. It looked like a pretty reliable website, and it was pretty easy to find the HTML pattern XPath to be able to search through multiple different pages to collect some more data. So here on the right, I have my Jupyter Notebook file that we're looking through. And as you can see, so the web equals, that's the original web page. And then once you're able to find the pattern, which is pretty easy, it basically just you just add the number of page onto the end of the uh, web address there to go to the next page. One interesting thing was I had to originally basically collect the XPath for, it was like the title of the article, and within that title there was a link to view more of that certain article. So basically we have a couple full loops here. So one is to grab uh, the sorry, I blinked a little bit. So grab the link for each article, and then the second loop is to basically go to each of those links, collect that text data, and then bring it back to us. So here, that the original link that I got from the first full loop didn't quite work. So as you can see, it's kind of got a couple dots and some backslashes there. And if you were to just click on that link by itself, if you weren't already internally in the website, it wouldn't work from an outside source, basically. So all I really needed to do was take those dots and backslashes out and then replace it with kind of like the what you could call like a home page of the website that we're crawling here. So that's kind of what we're talking about in the dot replace, and I replace that with the home page. So as you can see there, to collect my final data, I'm able to replace that first part of the link, and then my XPath is able to go and collect that from multiple different articles instead of uh, just one at a time. Uh, as far as cleaning the data, it was already pretty clean, honestly. I had to, as you can see, I had to take a bracket off. Then I put everything to lowercase, did some pretty simple removing, blanks or websites, anything that wasn't English, and words that, no, I removed any words that were three characters or less. Um, so the next thing I kind of went through was I made like a word cloud for some visual representation. And then all we're doing here is basically tokenizing everything so I can look at each token or word by itself. And as you can see, we've got some interesting ones like Amazon. That's a big one. Percent reports. Those all kind of make sense. We're trying to talk to business people. It looks like kind of a business journal Here, I would say the next most interesting thing that we worked with in class was sentiment analysis. So uh, the one that we used the most often was a Vader sentiment analysis. So we kind of went in here, and as you can kind of guess, it is like a business journal, business articles. So things aren't going to be super positive or negative if it's just kind of talking about facts of things going on, business trends. So it looks like we do have a slightly uh, positive sentiment from all of this text. As you can see, the mean score, it looks like a 0.16. As you can see above, we had a negative is considered negative 0.1, positive is 0.1. Anything in between that would be a neutral. So we do have a slightly positive sentiment with the text that we're looking at. The next another big thing that we did in class was network analysis. So basically all I'm doing here on the right on the HTML file is once again breaking these down into tokens, and then using the bigrams, then we're able to see which words go together with other words. And as we were taught in class, that this would be an easy way to then take this bigram file and then import it into Gephi and be able to do network analysis that way. So as you can see down here, this is the kind of the output or the network that I had as a final product. One thing that I'm going to kind of hop around here since we're talking about the network analytics here. So this network, it was pretty broken up. It's not very connected, if you will. The clustering coefficient was very low, and the density is also very low. And those statistics are brought in from Gephi. So we're looking at that. I did only collect 4 pages of data from this website. So I'm guessing that that's probably why everything isn't as correlated, because obviously there's going to be some correlation with problems that these people are having. If you kind of look through the data, one at a time, you can definitely see that there's reoccurring problems such as late deliveries, things getting to their stores on time. There's also as we'll talk about in our next topic, topic modeling. It looks like a pretty reoccurring cluster is like dealing with natural disasters, and how you can try to deal with the logistics behind that. So there obviously are correlations, but I think that to solve this problem, if we just simply collected more data, I think that we would see more connections. So basically what these statistics are telling us is that there are many nodes that aren't connected that could be connected. So I'm thinking that if we just, like I said previously, if we simply collected more data, we would be able to see more of these nodes be connected, and therefore get these statistics up a little bit. But some important insights that I thought were interesting from the network analysis. So the most popular terms or nodes in the network, once again, we're looking at suppliers, percent, product, new, Amazon, costs and deliveries, and then logistics as well. So, like I said, interesting there. Now, back to our next topic, topic modeling.